Good evening. We're going to tonight start with a new unit on fractions. Unit 4, Lesson 1, decompose whole numbers into a sum of unit fractions. Every fraction has a numerator, which is the top number. Then it has a fraction bar, and then it has a denominator, which is on the bottom. So 4/5, 4 would be the numerator, and the 5 would be the denominator. When we talk about unit fractions are like, for example, 1/2, 1/2, 1/3, 1/3, 1/4, 1/4, 1/5, 1/6, 1/7, 1/8, and then it can continue on. Unit fractions represent one equal part or a unit of a whole that has been partitioned, like been cut up into sections. Here we have some examples. The first one we have here that says this represents a whole, but this whole has been cut up, partitioned into two parts. It's broken up into a half. So we have 2/2, which represents a whole, and then we have another 2/2, which represents a whole. So that would equal 2 plus 2, 2 halves plus 2 halves, plus 2 halves, then another 2 halves. You're going to get 4 halves, which really is equal to 2 wholes. 1 whole, 2 wholes. Same thing happens for the next one. You have a whole that's been split up into fourths, another whole that's been split up into fourths, and if you add them all together, you're going to get 8/4, which really just means 1 whole plus another whole is going to give you 2 wholes. Then you can have this an example. This is a whole, and this whole has been cut up into 4 pieces. 4/4 is the same as 1. It could be 3/3, is 1, 2 halves, 8/8, 9/9. Anytime the numerator and the denominator are the same, they represent 1, a whole. Continuing on, we have 8 halves. We have 1, 2, 3, 4, and each one of those 4 have been cut up into a half, which is going to give us 8 halves. 8 halves is equal to 4 wholes. Down here, it's got a bigger numerator, 12/4. 12/4 is really equal to 3 wholes. 1, 2, 3. And these 3 wholes have been cut up into fourths. These fractions right here we're going to be using a lot, and they're called fractions greater than 1 or improper fractions. Fractions that are kind of misbehaving. They're not acting appropriately, because usually in a fraction, you're not going to have a numerator that's bigger than the denominator. Another way you could do by fractions is counting on number lines, by halves, for example. If you have 0 halves, that's just saying 0. 1/2 and 1/2. 2 halves, 2 halves, which is really just 1. 3 halves and 3 halves. 4 halves is going to give you 2. And then 6 halves is going to give us a 3 whole. 8 halves is going to give us 4 wholes. 10 halves is going to give us 5 wholes. When we want to decompose into a sum of unit fractions, decompose is kind of just meaning breaking down. If we take a 1 and we take and we cut that in half, we have 1/2 and then we have another half. We can actually decompose of that using a number bond and having the 1 and then taking a half away from that 1, and we're left with another half. A way to show this as an equation, 2 is equal to 1/2 plus 1/2 plus 1/2 plus 1/2. And then we could actually end up using these parentheses to break it up to make it more cleaner looking. So if we got 2 is equal to 1/2 plus 1/2, which is really just 1, plus 1/2 plus 1/2 is really just equal to 1. So 1 plus 1 is 2. The tape diagram represents 1. How is it decomposed? So we have a whole. So let's put our whole. And it's cut up into thirds. This is a third, this is a third, and this is a third. So how it's decomposed? Well, it's 1/3 plus 1/3 plus 1/3. Or we could say, parenthesis, 1/3 plus 1/3 plus that extra third. And that would give us 2/3 plus 1/3 is 3/3. Remember what I said. Anytime the numerator and the denominator are the same, they always equal 1 whole. All right, let's look at this one. This tape diagram is representing 2 wholes. But how do we know how to decompose this? Well, we know that we could break this up because half of 6 is broken up into 6 pieces. Half of 6 is really equal to a third. So 6, a half of 6 is 3. So we're going to break this up into 3 parts. This is going to be 1 whole, and this is going to be 1 whole. So in that case, how can we decompose it if you're breaking it down into thirds? Well, we can say 2 wholes, which this is representing, give us the parenthesis and say 1/3 plus 1/3 plus 1/3 group with the parenthesis plus, now we have to get the other whole, 1/3 plus 1/3 plus 1/3. And that is all going to give you 2 wholes, because 3/3, this is a 3/3 plus 3/3 is 1 plus 1, because anytime you have a numerator and the denominator the same, they always equal 1. Okay, in this next one, we have 2 different parts, the one in yellow and then the one in green. And the one in yellow showing this has been all cut up to show us 1 whole. But what has it been decomposed of? Well, it looks like it's been broken up into 1, 2, 3, 4. 4 parts, 4 equal parts. So in that case, we have 1, let's change the color here. We get 1 whole is equal to 1/4 plus 1/4 plus 1/4, and then another 4th. Okay, so that represents this section. But then we have another one, because then the green part is going now to 2 wholes. So now if we have 2 wholes, let's put 2, we are going to use our parentheses to make it nice and clean. All right, so this right here is 1/4 plus 1/4 plus 1/4 plus 1/4. That's going to give us 1 whole. And then we're going to add on this extra section right here, and that's going to be another whole. So 1/4 plus 1/4 plus 1/4 and another 4th, which is going to give us another whole. So 1 whole plus another whole is going to give us 2 wholes, because this would really represent 4/4, which is really equal to 1 whole. 4/4 is equal to 1 whole. So that's how we got 2 wholes. All right, this time we have the equation. And the equation is 1 whole is equal to 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. It's been decomposed. But how can we show this in a visual way? Well, we can use a number bond and put the whole inside, and then break this up into 6 different ones. So this is 1/6. Here is another 6. Here is another 6. So we could use number bonds to demonstrate breaking up and decomposing fractions. We can also use a number line, 0, and we're working all the way up to a whole. And how many pieces is broken up into? It's broken up into 6. So we go 1, 2, 3, 4, 5. And guys, you don't want to count the zero. You don't count the zero, but you do count the whole when you're breaking up your fractions. So here is 1, 2, 3, 4, 5, 6. You got to count that whole as your sixth one. And then show 1/6 on that number line. Well, it would be 1/6, 2 6, 3 6, 4 6, 5 6, 6 6. Remember, 6 6 is always equal to a whole. Another way of doing it is using a tape diagram. This is going to represent a whole, and we're breaking it up into 6. Very messy. I'm not very good at making sure that it looks all equal, but you get the idea. And then we fill in one box to represent 1/6. 1 6, 2 6, 3 6, 4 6, 5 6, 6 6 is equal to 1. Dear math, please grow up and solve your own problems. I'm tired of solving them for you. Don't we feel that way sometimes when it comes to math? What is the missing numerator for 2 wholes is equal to these fractions that are inside the parentheses grouped together, but they're missing the numerators? What's the missing numerator? What is the missing fraction? You have these circles, these number bonds, and they all equal to 1. What is the missing fraction? With plus the math, I can. So you guys can be able to do it. Don't give up. Fractions can be tricky, but they can be fun too. Have a good night.